Gradient of a vector v. Vector v is a first order tensor. Gradient of v, this will be, you see here, this will be partial respect to x1, v, a vector, e1, plus partial of v respect to x2, e2, plus partial of v respect to x3, e3. You see, this is an operator. There's an operator, see? Look. If I plug phi over here, this is a vector. Now I substitute, or I put inside this v. So this is a second order tensor. Now, you see, I represent in tensor notation, don't forget that v is equal v1 e1 plus v2 e2 plus v3 e3. So in tensor notation, I just write vi. This is vi. For I is equal 1 is v1, I is equal 2 v2, and I is equal 3 v3. So I can represent in tensor notation, I put like that. That's a partial derivative of vi xj. You see? That's a second order tensor. I and j are free indices. See, that's a second order tensor. Now, suppose, okay, on the first time, I want to see this. I want to see. Let's substitute v on each of these. So, let us develop gradient of vector v is nabla v. You see, this is nabla over here. So let's expand this. This will be e1 partial of v respect to x1 plus e2 partial of v respect to x2 plus e3 partial of v respect to x3. But v is equal v1 u1 plus v2 e2 plus v3 e3. And look, this is the orthonormal basis. This is e1, e2, and e3. That's the orthonormal basis. Now, let's substitute v over here. So this will be equal to e1 partial respect to x1. Now, v1 e1 plus v2 e2 plus v3 e3 plus, now, e2 partial respect to x2 of v1 e1 plus v2 e2 plus v3 e3 plus, now, e3 partial respect to x3 of v1 e1 plus v2 e2 plus v3 e3. Now this is equal, it is equal, now you see e1 e1, so this will be e1 partial of v1 respect to x1. plus, you see, this will be 3 terms plus 3 plus 3. This will be 9 terms over here. So this will be E1, E2, now partial of V2 with respect to x1 plus, now E1, E3, E3 partial of V3 with respect to x1. Now, this term over here will be E2, E1 partial of V1 with respect to x2 plus E2 partial of V2 respect to x2 plus E3 partial of V3 respect to x2. You see, 3 terms over here, 3 over here, plus now this term here will be E3 E1 partial of V1 with respect to x3 plus E2 partial of V2 with respect to x3 plus E3 partial of V3 with respect to x3. You see, look, this is a second order tensor. Now you can see interesting things here. You see, look here. You have E1 x1, E1 x1, E1 x1. You see, and this, okay, you have E1 V1 in this case. Okay, let's do this. I'll put, instead of this one here, I'll put the first one. Okay, because E1. So this is E1 over here. The same thing. Now you see the blue one. Now let's do this here. So this is E2, this is 2, this is E2, is the E2, and this is X2. You see the blue one? Now E3, X3, E3, X3, and E3, X3. We can do this, we can do like this. I sum what? You see, look, I put I, for instance, I is equal 1 to 3 of. Now, you see, this is 1, 1, 1, 1, 1, 1. This is 2, 2, 2, 2, 3, 3. Now, I'll put EI, okay. Now, you see over here that I have here 1, 1, 2, 2, and 3, 3. So this will be, I'll erase here a little bit, okay? Now I put this equal 1. Now a summation, another summation of j is equal 1 to 3. Now this will be E. Now partial of V partial of X. Now let's see. You see, this is E1 plus E2, so here will be EI. See, because I goes to 1 to 3. Now you see, for I is equal 1, I have also summation. Look, this is 1, 1, 2, 2, and 3, 3. You see, for I is equal 2, I have 1, 1, 2, 2, and 3, 3. So I can write here J. You see, this is I over here. I over here. See, when here is 1, this x, part of x1, part of x1. So when I is equal 1, I have a sum here, 1, 1 plus 2, 2 plus 3, 3 is a blue one. Now this will be partial of Vj. You see? Now, this here is the same as written here. Now, as we did by convention of Cartesian tensor notation, okay, you just eliminate the summation, eliminate the unit vector, and these are the component. So the component of nabla v, I just write partial of Vj partial xi. You see? And also I can represent this as a matrix. The whole thing here as a matrix. How we do the matrix, you see? Also, I could write like this. I'll write here. I could write like this: V, J, comma I. You see? V, J, comma I. So this is a second order tensor. See? You just work there. Now, what is the matrix? What is the matrix? Correspond to this second order tensor. You see, look. I write down, I write down with the unit vectors. So this will be, you see here, partial V1, I just put comma, V1, comma 1, E1, E1. Now, the second one will be, in this case, will be V2, comma 1, I write here. V2, comma 1, E1, E2. Now, here, the third one will be E1, E3, V3, comma 1, E1, E3. Now the second row, okay, will be here. Will be partial of V1, comma V1, comma 2, E2, E1, and here V2, comma 2, E2, E2. And there V3, comma 2, E2, E3. And the last row will be V1, see, V1, comma 3. V1, comma 3 here, E3, E1, E3, E1. Now, V2, comma 3, E2, E3, E3, E2. And the last one will be V3, comma 3, E3, E3. So that's a tensor. Now, we can write this, just representing as a matrix. So this matrix here will be v1, 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 v2, 1, v3, 1. Here will be v2, 1, v2, 2, and v2, 3 in this case. This is v1, 1, okay, v1, 2, now v2, 2, and v3, 2. The last row will be v1, 3. You see v1, 3, v2, 3, and v3, 3. So this is the matrix, and the elements of this matrix are v, j, I. Don't confuse here because you see, I here represents the rows and J represents the columns. You see, for I is equal 1, you have this row over here. For I is equal 2, this row, I is equal 3, this row over here. What's important for you to know that gradient of a vector is a second order tensor. We have two free indices over here. See? So here I can write like this. You see, this is nabla v. You see, nabla v is represented as a matrix, but in the Cartesian notation, we only work with components. So these are components. Or elements. These are elements of a matrix. Okay? Vji. It's important for you is gradient of V I represent as a second order tensor, partial V respect to X. Now, this is the elements of a matrix, a 3 by 3 matrix in R3 space. Now, if I write here, let's put P and Q, for instance. Okay? Q represents the rows. Q, the rows. And P, the columns. You have to see this from the previous derivation. Okay? These represent a row. For instance, what is the first row? The first row, you just put partial x1, partial x1, and partial of x1. See? That's the first row, like this. Okay? Now, for this column here, okay, you just put 1, 2, 3. Okay? First, this will be V1, the first column, V2, the first column, and V3, the third column. That's the second column, that's the first column. So here is first row. And those are columns. So column 1, column 2, and column 3. You can write for the second row and can write for the third row. It's important for you. That's important. You see, doesn't matter if it's I or J. Now, If you put I over here, I will be column. See? Now if you put, for instance, partial vi xj, obviously, j, you see, q is row. So j in this case, okay, will be rows, and I will be column. So it doesn't matter what you represent.